Hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics. Is going to be dealing with the second aspect of a potential elastic potential. Now in this case, I'm going to combine that one with kinetic energy and the aspect of our work, which is going to assist us give a general evaluation on how we can depict work or energy or this specific aspect of the forces which are going to be involved in stretching this spring from the initial to the final position given as such. We are going to consider this specific mass which is going to be acting on a spring from the initial position, perhaps which I can give from 1 to 2, whereby the forces which is going to be the force which is going to act on this spring is going to lead to a stretch over this spring by a distance which is going to be defined by the difference between those two specific quantities in length. Now in this case, we had said that force is directly proportional to the displacement, and therefore we had defined that we can give force in terms of the negative value of the change in the potential of the system, whereby we had said that this is basically the product of a spring constant times displacement given as such. And we can define the energy stored in this specific spring, and this is going to be in form of an equation set, which of course are going to assist us in trying to do this specific evaluation in showing the work or the energy involved. Now in this case, we said that energy stored in this particular stretched spring is equivalent to the value of work, and therefore we can consider small element of work being done by this specific object, which is going to be given in terms of or an element of work given in terms of a W, which is basically the force involved times the distance, which is going to be a displacement given as such. Now that we're going to consider this x displacement, and therefore we're going to give this particular distance in terms of the difference in x or the dx given as such. But we have said that basically force can be given in terms of negative kx. Therefore, we can find the work done, this element of work done by representing it using this element of a force, whereby we are going to have this specific representation given in terms of the element of work done is equivalent to the integral of this specific k x d. So summing up all this specific element is going to give us a general impression of the work done. But we're going to consider our displacement from this specific initial position to the final one given as such. And therefore, we're going to consider an integration for us to find the total work done in representing this specific aspect of the two different scenarios for x initial and x final, whereby we're going to have therefore this work done given in terms of the integral of negative k x dx given as such. And this is going to be considered from the initial position to the final, which we are going to give in terms of x initial and x final given as such. So doing an integration of this specific nature, then therefore we're going to have this one in evaluation. So we're going to have a negative value of k, which is a constant being taken out, and therefore that's going to give us the integral of x dx given as such from x initial to x final, giving us our element of work. And therefore in this case, we're going to find that work is equivalent to negative k, and the integral of that one is going to be x squared from our normal integration, and that is the difference from x initial to x final given as that one. So this is going to be giving us, considering this negative value, then this one is going to be giving us the negative value of k, and then we're going to have x final, the square of that one, all over 2 minus. So this is going to be a negative value again of minus k x initial squared all over 2 given as such. So we can do a rearrangement of this specific equation in order for us to find the final representation, or the final representation of this specific equation, whereby we're going to have this one given in terms of a half k into x final minus x initial. So this is going to be a subscript, and of course a squared given as that one. So this is going to form a form of a representation for the work done, which is going to be the work done in trying to stretch by this object in stretching this spring from the initial to the final position. And if we consider this specific stretch if we say x is equivalent to x final minus x initial, or the change in x, we can do a substitution for this one and come up with a general representation for that one. So perhaps I can do away with this, whereby we're going to have a w represented as a half k x squared, whereby we are saying that we're going to consider x as a displacement from the x initial to the x final given as such. So this is equivalent to the work done or the energy involved in trying to stretch this specific spring from the initial position to the final one. And in this case, of course, we are going to see that this element, particularly and this one, are going to be having an interplay in order for us to find the relationship between the work done, the amount of forces which are involved, and the nature of or the amount of displacement which we have shown in terms of x. Now, in our different evaluations, we're going to come across similar examples, which perhaps are going to require us to either to find the force, the work done, and the other aspects as we have shown above. So that is it for now, guys. I'd like to encourage our members to be checking our description boxes for various links of other videos. Subscribe to our channel and also ring that notification bell to be getting updates on various discussion in mathematics and sciences. So that is it for now, guys. Bye, God bless. We'll catch us in our next video.